this video, I introduce a generative pre-trained transformer. One neural network language model is used to predict the label of the input sequence. Its performance strongly depends on the size of the labeled training dataset. However, the labeled training dataset is limited and expensive. Generative pre-trained transformer splits a neural network language model into two sub-models. The first one is trained on an unlabeled training dataset in an unsupervised manner to embed the input into a general world representation that is for a wide range of tasks. For a specific task, the second model is used to predict the label of the input sequence. To get a pre-trained model, given the unsupervised purpose of the token, the model uses the context tokens as the input to generate the conditional probability of the current token UI. And then we use the conditional probabilities to define the likelihood of the tokens U. GPT uses a transformer decoder as a language model. Given the input, the model uses the context tokens as the input. Then embedding matrix embeds the one-hot vector input into a distributed world representation. And then the position matrix converts the world representation to a positional world representation. And then the transformer block uses it as the input to generate output distribution. And then we use this distribution as the input to the next transformer block until we get the final general world representation. And then we use this general world representation as the input to this softmax function to generate the conditional probability of words in the corpus. After we train the language model, the model parameters are used for the supervised training. Namely, we fix the parameters of the pre-trained model. And then use this input, the model generates this general world representation. For a specific task, we fine-tune this output layer to predict the label of the input sequence. And then we use this conditional probability to define the objective function. And then we combine the object function from output layer and from the pre-trained model, we define this overall objective function to train the GPT model. Because GPT 1.0 only can handle the sequence as the input. So if an input is sequence, we can directly fine-tune the model to generate the output. Otherwise, we need to process the input as the ordered sequence to the transformer to generate the output. Even we need to run a model several times independently to generate the output. For more details, please check with this reference. Thank you. Bye.